Hello, I'm Paul Goosens, and I'm joined by Bharani Mohan to talk to you about how MapleMBSE can connect all your key project stakeholders through rapid, error-free integration of their engineering knowledge with the systems model. In the context of the digital transformation of the engineering design process, we're seeing a major shift towards a more seamless sharing of information that comes out of the various engineering tasks. Traditionally, these tasks have tended to be very siloed, and the goal is to make the information more readily available between all the tasks. This creates a much more collaborative environment between the various design teams, their customers, and their suppliers. And systems engineering is one of the many tasks that needs to break down these silos. In our engagements with our customers, there are three categories of stakeholder that benefit from the use of MapleMBSE. The systems engineers like the fact that the information that they need from the subject matter experts is provided at the required level of detail in a consistent structure in the systems model, virtually free of errors. Not only that, by providing an intuitive user interface to the SMEs, there is a lot less resistance to using new tools because they require little to no training to use effectively. For the SMEs, they can provide their knowledge to the systems model without knowing anything about the underlying modeling technology. This enables effective cross-discipline collaboration between design groups throughout the organization. And for the program manager, this reduces the friction that's frequently inherent in the process by reducing errors, disruption, schedule overruns, and unbudgeted costs. So, how do we do it? MapleMBSE provides a synchronized bi-directional interface between the SMEs and the systems models. This provides the SME with a task-specific view of the model in a familiar Excel user interface for viewing, entering, and modifying system design information. Information entry is simplified for the end user, and data consistency is assured in the systems model. We currently provide integration with the standard SE platforms such as SysML tools like Rhapsody and Cameo Teamwork Cloud and Capella. And because there are many different tasks that MapleMBSE can be used for, we provide a powerful configuration and customization technology to create the task-specific views of the model and the Excel tool for the task. And these are just a small sample of the tasks that MapleMBSE can be used for. But really, it can be configured to integrate any task that is currently being performed in a spreadsheet. It can be used for tasks that require the specialist skills and knowledge of the SMEs. For example, to decompose high-level elements into detailed elements that can be designed and validated. A good example of this would be functional decomposition, which we'll see in the demo in a moment. And then there are tasks that require the integration of large quantities of information, such as equipment lists. This becomes much easier and quicker than importing them into a systems modeling tool. And even the systems engineer can find MapleMBSE very handy for performing structural analyses of the model or impact and traceability studies. Now we've given you an overview of MapleMBSE, let's move on to the demo. Bharani will show the use of MapleMBSE for functional decomposition. This will highlight how the systems engineer, working with Cameo Systems Modeler, interacts with the SME to break down the high-level function definitions into sub-functions, and then connecting them with the requirements they're designed to fulfill and the subsystems that will carry out the functions. Over to you, Bharani.
We will consider an activity tracker as an example to perform the functional decomposition. So the main function that we expect from a fitness tracker is we want to track our daily activity, like track heart rate, we want to track steps, we want to it to display notification, connect to a smartphone, and etc. So the main goal now is we identify a top level function, we then identify the lower level functions. We continue to the level of basic function. So basic function is what we could define as a function with the right level of detail. And then we define the input and what are the outputs for the function is going to be. We allocate the identified function to certain components. We can also link it to requirements to verify that the system requirements have been met based on the functions that we have defined and so on. So why functional decomposition is important? So it helps us to identify the functions that a system must perform. It helps us to identify the basic functions. We can link our functions to the system requirement to make sure that the system meets the requirement that has been defined. We identify the components to which the function is allocated to. It could be like either hardware or software and so on. And this also helps us to create different alternatives of our architecture, and also to perform trade studies and so on. So the way MapleMBSE can help with functional decomposition is we will identify the system functions. The user can define what the system has to do based on the requirement. We will decompose a function that we identified into sub-functions. We will trace or link the function to a requirement, and we will allocate the function or the functions that we break down to the components that are going to perform that functions. We will use SysML to perform functional decomposition. So I already have a model that is defined with certain requirements. There are already some functions. We want to identify new functions, and I have the functions linked with each other. The functions are already allocated to certain components, and we will see how from MapleMBSE a user can perform all these actions, save it back to the model, and we will see how they are being reflected as SysML elements, how they are linked with each other, and so on. So for the demo, we will have two user roles. One is the system expert, the other person would be a system engineer. System expert is the person who has the right level of knowledge but is not familiar with the modeling tool and the modeling environment. So they are going to use MapleMBSE to access the model, identify certain functions, decompose the function related to a requirement, and finally allocate to the component. And they are going to save their changes into the model. So as a system engineer, the system engineer is going to open the model in Cameo or in Magic Draw. We will see how these changes from the system experts are being reflected as SysML elements. Probably we'll make some change to the model, and the system expert can update their model in MapleMBSE to get the latest changes. I have the fitness tracker model already open here in the modeling tool. As you can see, we already have certain functions. We have requirements that are defined to identify functions. There are already structures that are defined for the model. So what I expect from the system expert is they are going to launch MapleMBSE, connect to this model, identify some functions and break down the functions into basic functions, allocate it to the components, and save it back to the model. So here I have the model already open in MapleMBSE. So this is the introduction worksheet where the user can know what each worksheet is about, like what view each worksheet is providing to a user. For example, the first worksheet refine requirements, so it is going to display requirements in that comes from the model, and what are the existing functions, and if the function are already linked to certain requirements. The functional decomposition, it's going to list all the functions, and we are going to see a breakdown of a function in level 1, level 2, and so on. For example, the track daily activity as a subfunction to display notification. Display notification is again further broken down into connect to a smartphone, sync data, turn Bluetooth, and so on. Final worksheet is the allocation matrix where we list the components, the function that is already in the model, and we can see how a component is related to a function. So we will add a new function. So for example, let's say to track daily steps. So I'm going to create a new function called track steps. And we are going to link track steps to the requirement track steps. So what this will do is this is going to create a relation between track steps and the requirement called track steps. So we have identified a function, a top level function called track steps, and we have said that this is going to be linked to a requirement. So here, as you can see, the track steps that we already created is also appearing in this worksheet. So we will identify sub-functions for the track steps, or we'll break down the track steps. So to track steps, the functions that are required are, say we wanted to find the altitude, pressure, we want to also determine the activity. So if the user is say walking or running, based on which we will say calculate the track steps differently, and then also to store data. So let me create a function called find altitude. So this automatically creates a function because we have created a new function, and we are also decomposing the track steps. So again, for track steps, I'm going to create another one called find pressure. Track steps. Now say determine activity. And store data. So I have identified few functions and decomposed the track steps into 4 other functions. So now I can go, the next step for me is to allocate which component are going to perform these functions. So you can again see the functions that we created from the previous worksheet appear here automatically. Let's say that I want to allocate the track steps to the 3-axis accelerometer. For find altitude, let's say the pressure sensor is going to help us find the altitude, pressure, the same component. For let's say to determine the activity, it is going to be the processor system, and to store data, storage unit is the component to which this function is going to be allocated to. So now I have identified the function and I have allocated the functions to the certain components that is going to perform these functions. I can save my changes to the server now by double clicking on the save button. So I'll see all G of G decomposition of track steps function added, and I'm going to click OK. So now I've saved my changes to the server. So to see the latest changes, what I will do is I'm going to update my project to get the latest changes. So I have updated my model, and we can see the new function track step appear here within the package called activities. So all this complexity is hidden from the system expert. The system engineer manages where the function has to be added, or from which part of the model the component has to be exposed to the user, or what requirement has to be exposed to the user is already determined by the system engineer. And you can notice that how easy it was for system expert to just launch MapleMBSE, connect to the model, and work with the view that they are comfortable with. So I'm going to create a new diagram here so that we could see the functions and its different relations. Now I'm just going to drag and drop the functions that was recently added, like the track steps, find altitude, pressure, store data, and also to determine activity. So here you can see the way the top level function track steps has been decomposed into other sub functions. This was also linked to say components like the 3-axis accelerometer, the pressure sensor, say the storage unit, and also to the processor subsystem. So here you can see how the changes that was done using MapleMBSE is being reflected as SysML elements with all the right relations and so on. Say now I want to make a change to the model. I want to link determine activity to the processor application and not to the processor subsystem. I'm just going to update my relation here to link it with the processor application, and now I'm going to save this change back to the model. I'm going to make my changes. And commit. To get the latest changes, I'm going to get to the add-ins menu, MapleMBSE, and we are going to update to get the latest changes. I'm going to see that a new revision is available and do we want to update it. I'm going to click on OK. So once the update is done, we are now going to see that the determine activity is now linked to the processor application and not to the process subsystem.
Thanks a lot, Bharani. I think you can see how the use of MapleMBSE can bring a great deal of value to your processes. And to help you realize that value quickly and successfully, MapleSoft provides a range of services, from training through application development support, to providing all the resources needed to do the configuration and software customization for you. To wrap up, MapleMBSE helps to break down the silos between engineering functions by accelerating the introduction of MBSE into your digital enterprise, and providing an easy way to capture and share the knowledge of your SMEs across the organization. This reduces project risk and unbudgeted costs. Many thanks for your attention. If you'd like to find out more, please visit MapleMBSE.com.